Let's solve Leetcode 74. Okay, so it's called search a 2D matrix. It's a medium problem. The problem is you're given an m by n integer matrix called matrix with the following two properties. Each row is sorted in a decreasing order. That's also ascending order. The first integer of each row is greater than the last integer of the previous row. Given an integer target, return true if target is in matrix or false. Otherwise, you must write a solution in big O of log n multiplied by n times complexity. Okay, so we have an example: 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 60. And target is 3. Naively, okay, what are we doing? We're looking for a target. We're provided a matrix 2D array and we're given a target. Naively, we could scan the target and find, we can scan the array, the matrix, line by line, or cell by cell, 1, 3, 5, 7, until we find a target. In our case, 3 is the target, we just return true. Okay, but we're given a hint here that we must write a problem that runs in big O of log m multiplied by n, m being the length of the matrix and n being the number of columns. So m, number of rows, n, number of columns. Okay, and we are given a hint that says each row is sorted, right? And the first integer of each row is also greater than the last integer of the previous row. Okay, so we're going to use these properties to implement binary search on the matrix. Okay, so what we'll do is we will need to do a two-step binary search. The first step is we'll do a binary search to determine what is the row that could potentially contain the target. So we're going to do a binary search where we're comparing the target with the first and last element of each row. So say we're looking for 3, we compare 3 with first and last. So is 3 bigger than this and is 3 less than this or equal to, right? So once we find the row that we need to search, then we need to search again. We will need to do classic binary search on that row to find the target. Okay, now let's quickly jump into the solution and code out the problem. So here we're searching for the row. Now let's get the number of rows and columns in variables. So rows is equal to matrix.length, and then columns, the number of columns will be equal to matrix, the first row dot length, because it's also an array. Okay, now we're doing a binary search to find the row, right? Okay, so we're going to use 2 pointers to represent boundaries. So we could do top and bottom boundaries. Okay, so I'm going to do int top is equal to 0 and bottom is equal to, since we already have rows, we can do rows minus 1 because we don't need integer out of bounds, array out of bounds exception, since we are going to be accessing indexes. Okay, cool. Now let's do binary search to find the row. But before we do that, let's put a variable row where we would find it. If we find the row, we'll just update that row. Okay, so classic binary search while top is less than bottom, less than or equal to bottom, right? So while this loop keeps running, we find the mid index between these boundaries. So we're gonna use integer division, and we'll do it this way to avoid integer overflow. So what we'll do is top plus bottom minus top divided by 2. And we're doing it this way to avoid integer overflow. Okay, so now what we're doing is comparing the first and last elements on this row. So we're comparing 1 and 7. We're using 1 and 7 first, 1 and 7 to compare against the target. If it falls in these bounds, then we would jump out of this loop. But let's do. What we're gonna do is if matrix, so the row is mid and the first element is 0, right? If this element is greater or equal to target, if it's greater or equal to target, okay. So if matrix, the first element is greater or equal to target and the last element is greater or equal to target, and matrix rows minus 1 is less than or equal to target. So we found our row, right? We can do row equal to mid, and then we break. But let's simplify this, right? One way to simplify this would be check if we should go towards the left, that's top, or we should go towards the bottom. And to go towards the top will be a situation where the last element is less than, sorry, the target is less than the last element, right? Then we'll need to go top. So say we're looking for, we're here on this row 20, and we're looking for 3. So we need to go top, right? We need to do bottom equal to mid minus 1. If we're here and we're looking for a bigger number, we need to go top equal to mid plus 1. Okay, all right, to simplify this case, let's do if target is greater than the last element, matrix mid, and then rows, or rather not rows, columns minus 1. So the target is greater than the last element on this row. It means we need to target, say we were looking for 20, 20 is greater than 7. It means we need to jump to the next row, which is plus 1, mid plus 1. So we'll do top is equal to mid plus 1. Okay, now another case is, say target is actually less than the first element. So we don't need to search on this row. If target is less than the first element, say we are searching for 3 and we're on this second row here, 10, 11, 16, 20. We're searching for 3. 3 is less than 10. So we need to jump back up here. Okay, so target is less than matrix mid 0. That's first element. Then what we need to do is go back up. So we do bottom. Bottom is equal to mid minus 1. Okay, so now to simplify this one, this case here, we just do an else. Because if the first and last element, these two cases doesn't match, then we'll just take the else condition here to handle the case where the element is greater or equal to this and also less than or equal to this. So that we'll search on this row. Okay, so now row equal to mid, and we break out of this loop. Once we break out of this loop, we will do classic binary search, another classic binary search to search on this row. Okay, so now let's use different pointers for this time. So int left is equal to 0 and right is equal to, we can do columns minus 1. Okay, and then while left is less than right or equal to right. Okay, let's run this loop. While left is less than or equal to right, we'll need to do equal to because we want the pointers to meet and also search at that index. Okay, now we use the mid point to get the middle of the index, the middle of the boundaries, left and right boundaries, and then see if the element is at that index. So to avoid integer overflow during division, we're just gonna do left plus right minus left, and then divided by 2. Okay, now let's see if the item or element at that index equals our target. That's the first case. If this case is met, we return true. We found the target. Now, another case is, okay, take it back. All right, now we are on row. We know the row where we are searching, so it's called row, and we're searching column by column, right? Okay, so we do if target is greater, so we're taking care of the case where it is greater than the number, the current index, where we need to search to the right. Okay, so say target is greater than matrix row, and we know the row. We found the row which is here. Okay, matrix row and mid, right? Yeah. Mid is the current index. If target is greater than matrix row mid, then we haven't found the target. The target is somewhere up to the right. So we need to move towards the right. So to do that, we'll do left is equal to mid plus 1. Now, another case is when target is less than the index. If target is less than matrix row mid, then we need to move towards the left. So to do that, we do right equal to mid minus 1. Now the last case is the case where, okay, obviously if it's not greater, target is not less than, and target is equal to that value. And when it's equal, we can immediately return true. Okay, when this loop ends, when left passes right, when they go past each other, then this loop will jump out. Then we need to return false because we could not find the target. It means that this condition was, or rather this condition was never met. Left kept changing and right kept changing, but this condition was never met and the loop ended, so we return false. Okay, so that should be the solution to searching the target in the 2D matrix where it's, having these properties. Each row is sorted and the first integer on each row is also greater than the previous one. Okay, so let's run this and see if it passes the test cases. Okay, so we have a failed test case, target 13, output true, expected false. Okay, let's go and see what we did wrong. Okay, I think I might have missed to put an else here because using an if and an if would be a logical error. So here we don't need an else for this case because it's a one-way. If it's greater, we move to the right, or we move to the left, or we return true. Okay, so the error was the missing else for this block. So let's run again and see if our test cases pass. Okay, so now our test cases have passed, and let's submit the solution again, and great, our solution was accepted. So that is it for this video. I'm sure it did help. So please like and subscribe to my channel, and I will see you in the next video. Thank you so much for watching, and bye bye.